Israel company Sea Underwater Eye has developed the underwater high data rate ultrasound communication link. Yusim described the test of the system in the pool of engineering department of Tel Aviv University. Here you see the pool and the equipment that include ultrasound transducer on the X, you see it now, that are installed in the special frames permitting to change the depth and angle position of the transducers. The frames are set in the pool in the opposite side so that one transducer can communicate with another. This frame and X permits to set the needed depth and the direction of the transducer. Here is the transmitter on the X. You see the frame and the screw that fixes its position. And in the opposite side you will see a receiver. Here it is. These transducers are designed and manufactured by the Airmar company in accord with our demands. Here is the X of the receiver. These transducers are set in the pool at the depth about half a meter, and the range between them about 2 meters. You see the scale that permits you to understand the sizes of the transducers. The X can be put out of the frame and installed after that. Here I change the direction and the depth and fix the needed position by the screws. Maximum acoustic output power of the transducer is about 10 watt. Transducers works on the frequency 300 kHz and are connected with the amplifiers and the digital signal processor boards. You see the transmitting electronics and transmitting personal computer. We used its installed TV camera to transmit the video images from this computer to the transducer, to the transmitter, and after that these images are received by the amplifier of the receiver that is connected with the receiver, and information from this amplifier and digital signal processing unit goes to the personal computer. In such kind we form the video images to be transmitted. We test the influence of the movement of the object before the TV camera on the quality of the images on the receiver screen. In such a way we understand that really our system permits to transmit the movement of the object with the speed no less than 1 meter per second when it is before the TV camera. The transmission goes without delay. We could not feel this delay really. Maybe because of the range it is not so large, only 2 meters. But really the transducers permits in accord with their parameters to transmit the images at the range up to 1000 meters in the water. You see the receiving computer. Here this you see once again amplifiers and DSP. DSP realizes QPSK modulation. Here you see the movement of the person and how we can catch these images on the receiving transducer. Here you see once again movements of the arms, and to the right of the images you see how the information packets comes to the receiver. They are decoded by our programs, and after that we can receive the images. We try to understand and to show that is a real-time transmission, and but the resolution of the camera is rather poor, so we did not manage to see the clock properly. But you could believe that it is really a real-time communication. Here you see the packets on the link. The scope permits to control the quality of the transmission line. Here you see once more how we transmit the images. We could record it from our TV camera, or simply we could record it just from the screen of the computer with special program. The quality is much better in the last way. Here you see how we transmit the images and how the packets comes to the receiver. The distance between the person and the TV camera from which we transmit the images is about 10-20 centimeters. That's all. Thank you.